This video is to focus on the difference and the similarities between isosceles triangles and equilateral triangles. More specifically, how do I apply their properties? In the isosceles triangle, you need to recognize that we have two legs, one base, and two base angles. My legs are my congruent sides. Okay. It could be these two sides, but I might rotate my triangle. And now these are my two congruent sides. That makes these my legs. I'm just going to label them with L here to save time. I also have my base. My base is my third side, my non-congruent side. That makes, in the first diagram, the bottom my base, but don't get caught thinking that the bottom is always the base. In the diagram on the right, you can see the base is not always on the bottom. Base angles are the two angles that go along your base. Your base touches two vertices, touches two angles. Those are my base angles. So they are the congruent angles along the base. In diagram 1, that's these two angles. In diagram 2, I can mark these two. Also recognize, notice, it is the congruent side, and congruent angles are always opposite. We can say in shorthand, that's isosceles. We can also conclude that my angles, my base angles, are congruent. Equilateral is similar ideas in the fact that I have congruent sides, but in this case, all three sides are congruent. And in addition to that, because all three sides are congruent, the angle's opposite, meaning all three angles are also congruent. So using shorthand, all three angles congruent. But we can take that one step further. Using the triangle sum theorem we talked about and showed that because they are all congruent, and triangle sum says they all add to 180, I know that each angle is 60 degrees. Those are the most important properties that we need to be able to apply about isosceles and equilateral triangles. Now, I've got a few examples here that I want to work through. The first two are actually the harder of the five different examples here. And this gets to the point that we absolutely must pay very close attention to the details in the problem. I know that I have an isosceles triangle CPR. You can start this by drawing a triangle and labeling everything CPR, or drawing an isosceles triangle. This is the way I would recommend. Labeling what we know about an isosceles triangle, I have two congruent sides and my congruent base angles, the angles opposite my sides, before I label my vertices. Now read the rest of the problem and decide what is my base, what is my vertex. Here they are giving me different side lengths, which I can't do anything with yet. I have to first go to the last part now. Find the value of x if segment PR is the base. That's the key piece of information here. That means I have to label this. My congruent base angles are P and R, which makes C up at the top here. That's my vertex. Now I'm going to utilize this information that they gave me. That segment CP has a length of 8x plus 11. So this is 8x plus 11. That segment PR has a length of 4x plus 23. And that segment RC has a length of 3x plus 46. Without knowing where to put my points, I don't know how to label the sides with these expressions. And now that I know I have my points labeled accurately, sorry about that, I know which sides are congruent. I had already marked segment CP and segment CR as my congruent sides because PR is my base. Those are my congruent sides. That means this 4x plus 23 is just extra information. And in order to find x, I just set 8x plus 11 equal to 3x plus 46. And then through the magic of algebra, we find that x is equal to 7. This isn't an algebra video. it's a geometry video. The geometry here is to make sure you label your triangle accurately. I'm going to erase this part because this is a tricky problem here in number 2, and it's definitely one that I would want to know if I were preparing for a test or a quiz. Because they're giving me 2 different pieces of information. They have a perimeter of an equilateral triangle is 9x plus 12. Well, I know I'm dealing with an equilateral triangle. So I might start by drawing it and labeling it. I also know my angles are congruent, but I haven't said anything in here about angles. So what I really have is 2 scenarios here. First, the perimeter is 9x plus 12. That's an equation. Perimeter is 9x plus 12. Second, they tell me that one side length is 2x plus 8. Well, it doesn't matter which side I choose because they're all 2x plus 8 then. I can write this perimeter with a completely different expression because of the 2x plus 8. So ignoring that I told you that the perimeter is 9x plus 12, take into consideration the fact that one side is 2x plus 8, meaning the perimeter would be 2x plus 8 plus 2x plus 8 plus 2x plus 8, or 3 times 2x plus 8. What's nice now is I actually have a system of equations. This is both what the perimeter is equal to. I can substitute. I can get rid of the perimeter here and replace it with 9x plus 12 because I have been given the perimeter in 2 different ways. But the perimeter is the perimeter. So either way, it's equal, meaning I have 9x plus 12, that's the perimeter, must be equal to 3 times 2x plus 8 because that's also the perimeter. And now I have an algebra equation with variables on both sides. And again, the magic of algebra allows me to go to my answer, x equals 4. Be ready to answer a question like that, at least setting that equation up, getting to this point. The rest of this is algebra. I expect us to be able to do that. If you're confused on either number 1 or 2, this is a good time to go back and review. Rewind to those parts, watch the video again, maybe try it on your own, then watch the video again. But that's a good skill to get in the habit of doing. The last 3 problems are a little bit more straightforward. Now, in number 3, these 3 sides being marked congruent means this is an equilateral triangle, but if it's equilateral, it's equiangular. If it's equiangular, my angles are 60 degrees. There's the chain rule of logic again, back to Unit 2. I know that this is 60 degrees, I know that this is 60 degrees, and I know that this angle here is 60 degrees. That allows me to set my equation up. 3x plus 24 is 60 degrees. This is an angle measure, so I am allowed to use that. The magic of algebra, and x is 13. In number 4, it's an isosceles triangle. These are my legs, which makes this side my base. That means these angles are congruent. My base angles are congruent. Well, I have a 32-degree angle for my vertex. My other angles must be equal. Triangle sum. Triangle sum says that when I take 180 and I subtract the 32, I get 148. But that 148 has to be split equally between these 2 angles. Divide this by 2, and y must be a 74-degree angle. So again, recognizing which angles are congruent, and it's my base angles along my base, my non-congruent side. Those are my congruent angles. Triangle sum gets me these 2 together. Dividing them by 2 because they're both equal gets me 74 degrees. And finally, it's the same idea, only in the opposite direction. I'm told these are my congruent angles. Since this is the side that touches both angles, that makes this side my base. If that's my base, my other two sides are my legs, and in an isosceles triangle, it's your legs that are congruent. So that is what I am setting equal. The 30 is unnecessary information in this example. 5z is equal to 40, and that makes z equal to 8. Make sure you rewind and rewatch any of this that you struggled with, that you have questions on. Write down any questions you have, and feel free to come in and ask me. Also, make sure you try the practice quiz.